Here is a line. What is the length of the line? Simple way to find out. I put a ruler and I find 10.1 inches. I can take another ruler, measure it again. I measure now 9.9 inches. Then 10.2, etc. I take everything and I average it out to decide that my best estimate of the value of x is this. Is there another way? Could we think of a completely different way to find the value of x? Here is what I do. I put this segment of the unknown length inside a larger segment of known length. This, from here to here, is 20 inches. Known. What I don't know is how much x. So, let me point your attention to this magic box. This is a box, magic. Every time you push this box, it shoots out a number. A number between 0 and 20. If the number that it shoots corresponds to a point here that is inside this segment x, what comes back is the number 1. If, on the other hand, it shoots a number here, outside this x, what comes back is the number 0. And I keep pushing. 1, 2, 3, many times. Every time I push this magic box, I get a randomly selected number that may be any number or point to any point between this and that. And every time that it hits this segment, I return a 1. Every time that it misses it, I return a 0. First of all, there is no question of accuracy like we had before. It's zeros and 1. Reminds you of something? Now, let me write here an equation. X to 20 equals the number of hits 1 to the number of shots, or H to S. We could say more or less it's getting close. So if I know 20, of course, I know how many shots I shot, I know how many of them were hit, so I know everything, I can calculate x. And the amazing part here is that the more times I push this button, this ratio gets closer and closer to the value of x. Before, when I use the ruler, it depends on the accuracy of the ruler. It had a limit. I cannot measure with this ruler the value of x more than, let's say, 1/10 of an inch. But with this method, as long as this is purely random, I can get the value of x to any desired accuracy. Well, you could say it's a nice academic thought experiment. Magic box shoots random number, you count hits, shots, you do this. Yeah, it would work as long as there is such a magic box, which we know it doesn't. That's the big discovery of the 20th century. And it's bigger than relativity. The discovery of physics of the 20th century is that this magic box, this academic exercise, represents reality in the microcosmos. See, as soon as we go down, like Alice in Wonderland, into the microcosmos, we see those boxes like mushrooms in the forest, everywhere. We don't know how they got there. We don't know who put them there and for what purpose, but we know that they are there. In the 17th century, Isaac Newton discovered gravity. And he was baffled. He had no idea where it came from. No clue how the sun knows that the earth is there to be pulled. Still, he said, it's there. And I can describe it mathematically. And with these equations, we can now build high-rises, bridges, roads, boats, cars, airplanes, all based on Newton's law that described gravity without understanding where it came from. Hundreds of years later, Albert Einstein explained to us where it came from. Well, a few hundred years down the road, someone will explain to us where this magic box came from. But right now, the same way that Newton used the existence of gravity to build technology, we are using the existence of this magic boxes to build quantum computers, to practice quantum cryptography, to win the cyber war. That's what we are looking for. That is what's ahead. Exploitation of the random number generators in the microcosmos to live